is circles. So we have an equation, and we need to see if this is a circle or not. So the first thing I'm going to do is I'm going to move this 106 over. So I'm going to rewrite this one, and this is 2.2. We're going to begin with question 10. I'm going to rewrite this as x squared plus y squared plus 18x minus 10y, and I'm going to move that 106 over. So that's going to make it a minus 106. So the first thing we want to do is we want to make sure that we move the numbers to the right, all the variables go to the left. Are we finished? Okay, yep, I'll get it ready for you then. Give you the new homework. Well, I'll give the whole packet here in a minute. So we're still looking at questions out of 2.2. So we'll look at 2.2. We're going to look at question 10. And so what we want to do is we want to complete the square twice. So we'll look at the x part. And how do we complete the square? Well, we complete the square by halving and then squaring. So what is half of, let me write it out here. What we've got x squared plus 18x. What's half of 18? Half of 18 is a 9, and 9 squared is a 81. So that 81 is going to have to be added back in. So what we do is we half and square. Okay, so half and square. And we're going to do the same procedure for the y part. So the y part's over here. And for the y part, we have y squared minus 10y. So we half and square. So what's half of a negative 10? Half of a negative 10 would be a negative 5. And then we square it. What happens when we square negative 5? Well, it becomes a positive 25. Remember that? Okay, half and square. Now, what does it look like when you put all the pieces back together? So what do we have on the left-hand side? Well, on the left-hand side, we have x plus 9, quantity squared. We have y minus 5, quantity squared. And what about the right-hand side? We have a minus 106. We have a positive 81 and a positive 25. We'll put those together. Okay, that gives you then, when we add these over, it gives you then a 0, doesn't it? We put them together. Now, what is my center going to be? Can anyone tell me what my center would be? Remember, we've done this many, many times. Okay, when we want to find our center, what do? Switch the signs. So that's going to be a minus 9 and a positive what? 5. And what's my radius? Square root of 0, which is what? 0. Now, if your radius is 0, what is it? Can you have a circle with radius of 0? No. Since the radius is 0, it is the point minus 9, positive 5. Okay? So since that radius is 0, it is just going to be the point minus 9, positive 5. Does that make sense on that? Because what you'll do is half and square, put it back together, and if your radius is 0, it's a point. Now, if that would have been a negative number, the graph would be non-existent. And if it would be a positive number like 9, then you would take the square root of 9, which would then simply be 3. And so your radius would be 3. So in this case, Radius is 0, so it is simply a point. If we didn't have any questions out of 2-3, then I did pick some out of 2-4 to look at. Because we covered almost all of 2-4 last time, but we'll look at the ones that we haven't. And I picked question 14. So we're going to look at question 14. And we want to graph the line and give the domain and the range. So we want to graph the line, and we want to give our domain and our range. And so what we've got is we've got 2y plus 18 equals 0. Okay, so I want to graph this line. Now, if we want to graph a line, what do we have to solve for? We try to solve for the variable what? Y. So let's take this and let's solve it for the variable y. So we'll solve this for the variable y, and then we'll graph it. So I'm going to begin by moving that 18 over. And that leaves you then with 2y equals a minus 18. We'll divide by our 2, and so y now equals a negative 9. How do I graph y equals a negative 9? Would this be a vertical line or a horizontal line? We know it's not a diagonal, right? What axis does it cross? It crosses the y-axis. And where does it cross the y-axis at? Negative 9. So it's going to look like this. Down 1, 2, 3, 4, 6, 7, 8, 9. So just kind of sketch the graph over to the side. And here's your graph. Now we need to find the domain and the range. What would the domain be? Does anyone know what the domain would be? Anyone want to take a guess as to what the domain would be? No. What does the domain go with? A domain goes with the values of x. Does this go to the left? Yes. Does this go to the right? Yes. So what's my domain? My domain would be negative to positive infinity, right? Because it goes to the left and it goes to the right. What about the range, the up and down part? Does this go up or down at all? No. Where is it stuck at? On the y-axis. Where is it stuck at? It's stuck at negative 9. So there's your domain, and there is your range. The range is the up and down part. The domain is the left and right part. Let's do some more of these. I also picked question 15, just so we would understand how to graph these. How would I graph this? Well, we need to remember that this g of x, that is the same thing as having a y. So that g of x is the same as y. Now, what do we know about our slope? There is no number in front of the x, so my slope then would be a 1. So my slope, m, is 1, and this is your y-intercept. And that would be 0, negative 6, right? Okay, so we want to graph this function, and we also want to give the domain and the range. Where do we start at? We start at our y-intercept, and where is that at? That is down 6 units. And then what are we going to do? What is my slope? 1 over 1. So up 1 and over 1. So up 1, over 1. Make our new dot. Connect them together. And so it looks like that. Now, what is my domain and range? Can anyone tell me what the domain and range would be? I know we went over this before. Does anyone know what the domain and the range would be? I'll give you a hint. The domain and the range are going to be the same. Can anyone tell me what the domain and the range would be? Does anyone know? Domain, remember, is the values of x. So this is going up and to the right, down and to the left. So it goes left and right, so it's negative to positive infinity. And your range is also negative to positive infinity. On all diagonal lines, the domain and the range are the same. So they're always the same. Question 16 is similar again. We're going to be graphing question 16, and I picked this one because it's missing a part. This h of x, well, that is like your y. So what would my slope be? Well, the slope is the number in front of the x, so that is m equals a negative 5. What about the y-intercept? Is there a number on the end? No. So that is like having a plus 0. So my y-intercept would be 0, 0. All right, so we're going to start at 0, 0. And then my slope is a negative 5. So how is that going to work? We plot our point right here at 0, 0. My slope is a minus 5 over 1. So we go down 5 over 1. So down 5 units and over 1 unit. Make our new dot here. And then we connect them together. What is my domain and range? We just talked about this. Does anyone know what the domain and the range would be? We just did this a moment ago. Does anyone remember what the domain and the range would be? Does anyone want to take a guess as to what that would be? Well, what was the last one? This is a diagonal line. Your domain and your range were what? Negative to positive infinity, right? Now, this one is also a diagonal line. So what do you think your domain and your range will be? The same. So it's also going to be negative to positive infinity, right? All diagonal lines are always negative to positive infinity for the domain and the range. One more question, and then we'll move on to the next section. So let's look at question 19. There are 4 choices here, and I want to figure out which one has a y-intercept of a negative 3. Why can I eliminate choice A? what would the y-intercept of choice A be? What would the y-intercept of this choice be? This one would have a y-intercept of what? 23. Because that's your number on the end. So A is not going to work. What about B? If I move it over, you get 9y equals 3x, right, plus 23. And that gives you y equals then, when I reduce it down, 1/3 x plus 23 over 3. What do we want? We want a y-intercept of -3. That is not -3. So that one does not work. What about this one? It has been solved for y or f of x. They are the same. The number on the end is a -3, so it has a y-intercept of -3. This one over here has no y-intercept. So this one has a y-intercept of 23. This one has a y-intercept of 23 over 9, right? And that's not 3, -3 like what we want. This one has a y-intercept of -3. So those match up. So question 19, the answer should be C. If we don't have any other questions, then we'll go ahead and start the next homework packet. So I'll pass out the new homework packet. I broke it up because there's just so much in here, so I wanted to make it a less big of a pack. So that's why I split it in half. We'll have our exam after we finish chapter 2. It'll be way after spring break. It'll probably be the week after spring break. Oh, you need that one? Okay, I've got an extra one of those too. The very first one? Yep. Okay. I've got a couple of extra copies of that, so I'll find them up here. Okay. Let's now go ahead and start 2.5. So we're going to now begin 2.5, so you all should have that homework packet. We're going to begin looking at 2.5. And 2.5 is all about finding equations of lines. So we're going to be looking at standard form, and we're going to be looking at slope-intercept form as well. My homework packets here. Get started here. So we're going to be looking at slope-intercept form and standard form. When we go to find equations of lines, there are two different forms that we can use. We can write our answer in either standard form or slope-intercept form. So let's look at the two different forms and we'll convert them back and forth. So this is going to be slope-intercept form. And this is the one that we've already done. And slope-intercept form is y equals mx plus b. or you can have what's called standard form. And standard form is ax plus by equals c. And when we look at standard form, no fractions or decimals. So no fractions or decimals. And a must be positive. So those are the two ways that we can write our answer. We can write our answer in either slope-intercept form, or we can write it in standard form. Now let's convert them back and forth. So I'm going to give you one, and we're going to convert this one to standard form. So we're going to be trying to convert this to standard form. And this one's going to be very easy to write in standard form. So what does standard form look like? This is what standard form looks like. The x's and the y's are on the same side. No fractions and no decimals. So how do we convert this one to standard form? It's pretty easy. All we need to do is move the 9x over. Now, here's where students make a mistake. This is not quite in standard form. Why is this one not in standard form? Yeah, because the number in front of the x, the a, must be positive. So if this is negative, how do we fix that? We distribute a negative through. And when I distribute the negative through, that makes it a positive 9x, which is what we want, a minus 4y, and that's going to equal a negative 2. So we converted that to now standard form. Let's do another one where we convert it to standard form. So I want you to now convert this one to standard form. Well, the first thing I need to do is I need to get rid of the fractions, because in standard form, we cannot have any fractions. So how do I get rid of the fractions? Well, we need a least common denominator of 3 and 5. And that would be now 15. So I'm going to multiply all of this by 15. And so 15 divided by 3 is a 5. So that gives you a 5x. 15 times 5, we'll need a calculator here, but I believe that's 75. Yep, remember, serves me. It's going to be a minus 75y. And then 15 divided by 5, that makes it a positive 3. Now, how do we get this in standard form? To get it in standard form, we need to move this y over. So I'm going to add the 75y over. And now we have it in the correct order. The x always goes first. So that is 5x plus 75y equals 3. So we now have it in standard form. Right? So all you have to do is rewrite it to where the x and the y are on the same side. No fractions, no decimals. Now, what we're going to be doing next is we are going to be working with finding the line equation. And there are three ways that we can do this. We can find the equation of a line when you're given a point and a slope, 2 points, or a point and a line equation. And each of these have a flow chart. And so we'll start with the first one. And we're going to be finding the equation of a line when you're given a point and a slope. So we're going to find the equation of a line when you're given a point and a slope. So let's see how we would do that. This is like a recipe. We follow it. So we want to find the equation given a point and a slope. So that's what we're going to be doing. Okay, we're going to find the equation when you're given a point and a slope. So this is what we want to do, and we just follow it. Now, what we're going to do, since we have a point and a slope, is we're going to follow it down, and we're going to use point slope. And the point slope formula is y minus y1 equals m times x minus your x1. And then we'll either go over here to standard form or slope-intercept form. We'll go over here to slope-intercept. Which is y equals mx plus b. Okay, so this is what we're going to be doing here. And this is the absolute easiest way to do these. I know you've seen these in other classes before, but this is the easiest way to do them. So this is a flow chart, and a flow chart is just basically a recipe. We just follow the directions. So we want to find the equation given a point and a slope. So if we have a point and a slope, then we can proceed and we can use our point slope formula. And then we either write our answer in standard form or we write our answer in slope-intercept form, depending upon which one it asks you to find. So now we're gonna work out a couple of these. We'll do 2 examples of each type. And then we'll look at some special cases. So we're going to try to find the equation in, let's do this one, standard form. And you're going to be given a point and a slope. So I'll give you a moment to think about what we have. Now, what are we given? All right, we are given a point and we are given a slope. So this one goes here because we want to find the equation. We are given a point and we are given a slope. So we use the point slope formula here. So this is what we're going to be applying. So what I always do is I rewrite my answer. Now, my formula. Now, what does it need to look like? At the end, it needs to look like this. So let's write up our formula. And the formula that we're going to be using is we're going to use our point slope formula. And that is y minus y1 equals m times x minus your x1. And this is your x1, and this is your y1. So we'll go ahead and fill it in here. And let's see what we've got when I fill my pieces in. So filling it in, watch your signs. We have y minus a minus 2. Be careful with the signs there. Equals a minus 2 times x minus 5. So we just plugged our values in. y1, x1, right? And now we can finish it because a double negative here makes that then a positive. So that's y plus 2. On the other side, we're going to distribute the negative 2 through. And that gives you then a minus 2x. Negative and negative makes it a positive 10. And what form do we want this in? Standard. And what does standard form look like? That. So let's make it look like this. And how do we do that? We just did these a moment ago. We're going to add our 2x over and subtract off our 2. Now we have our answer in standard form, which is 2x plus y equals 10 minus 2. So that's an 8. And there's your answer in standard form. Okay? Let's do another one. We'll do 2 of each type. So we'll do 2 where you have a point and a slope, 2 where you have 2 points, and 2 of them also when you have a point and a line equation. So same directions. This time, though, we're going to get it in slope-intercept. So we want to find the equation in slope-intercept form. And let's say you're given a point and a slope again. So how about you're given the point 1, negative 3, and a slope of minus 2/3. So the first thing we do is we identify what we have. And what do we have here? Well, we have a point, right, and we have a slope, don't we? So we're going to apply our point-slope formula. So let's write up our formula, which is y minus y1 equals m times x minus your x1. This is your x1, and this is your y1. We're going to fill it in, and that's going to give you y minus a minus 3. Watch out for the double negative there, because that's a double negative again. And that equals minus 2/3 times x minus 1. And what do we know about the double negative here? Makes that positive. So that is then y plus 3 when we distribute that through. And over here, we're going to distribute our fraction through. And so it's going to then equal a minus 2/3 x. Negative and negative makes it a positive 2/3. I would clear the fractions. You could just subtract that 3 off, but I think it's going to be easier if we clear our fractions. So we're going to multiply it by 3, just to clear out the fractions. And that is then 3y plus 9 equals a minus 2x plus 2. And what do we want our answer to look like? We need to make sure our answer looks like what? We want it in slope-intercept form. So it needs to look like that, right? Slope-intercept form looks like that. You just follow this flow chart. So this is what we've got. We need to solve it for y. So I'm going to move the 9 over. And And that leaves you then with 3y equals a minus 2x. 2 minus 9 makes it a minus 7. And we'll divide by our 3 everywhere. And that leaves you then with y equals a minus 2/3 x. Watch your signs here. Minus 7/3. And that is your answer in slope-intercept form. And there are different ways of doing these. I think using the flow chart is the easiest way. So now we'll create the next flow chart. And for the next one, we're going to find the equation. Given 2 points. So we want to find the equation when we're given 2 points. How do we do that? Well, follow it down again. You want to find the equation when you're given 2 points. The first thing you do is you find the slope. Which, remember, your slope formula is y1 minus y2 over x1 minus your x2. Once you've got that, then what you do is apply your point slope formula. So you find your slope, and you apply the point slope formula, which is y minus y1 equals m times x minus your x1. And then you either express your answer in standard form or in slope-intercept form, just like the last piece, or the last question. So standard form looks like this. ax plus by equals c. And slope-intercept form looks like this. Slope-intercept form is y equals mx plus b. So there's your standard form, and there is your slope-intercept form. It's basically the same as what we just did a moment ago, only it has one more step. You have to find the slope first. So we'll do 2 of these. So let's find the equation in standard form. And let's say you're given 2 points. How about you're given the point 5, 4 and minus 3, 7. So let's go back up and look at our flow chart here. So what are we trying to do? Let's make sure we know what we're doing. Why am I going to use this one? It says find the equation given 2 points. So what do we have? 2 points. So we follow it down. This is just like a recipe. So here is what I do next. And what do I need to do? I need to find the slope. So this is x1, and this is y1. This is x2, and this is y2. So we're going to find the slope. And that is m equals, write up our formula, y1 minus y2 over x1 minus x2. Filling them in. Watch out for double negatives if you have any. Filling them in, that's 4 minus 7. divided by 5, watch for double negatives, minus a minus 3. Double negative here makes that positive. And 4 minus 7, well, that's a minus 3. And 5 plus 3, that makes it an 8. Is everyone okay with that? So we found our slope. Now, once we have the slope, then what do we need to do? Once we have that slope, then we need to use point slope. And we're going to use the point slope with our first point, which is 5, 4, and the slope that we found, which is minus 3/8. So what we did was we found our slope. Then we went to our point slope formula, because this is our first one. So this is x1, y1. And what's our formula? Well, it is y minus y1 equals m times x minus your x1. And we'll fill this in. So that's going to be y minus 4 equals minus 3/8 times x minus 5. Is everyone okay with that so far? Now we just clean it up, and we want this one in standard form. So we're going to distribute this fraction through. How do we distribute the fraction through? Well, we just multiply. So that's going to be a minus 3/8 x there. What about this one? That's like a minus 5 over 1. Minus 3 times minus 5, that makes it a positive 15. And 8 times 1, that makes it an 8. And the left-hand side is y minus 4. Now, can we have any fractions in standard form? No. We are not allowed to have fractions in standard form. So we multiply everything by an 8 to get rid of the fractions. And that leaves you then with 8y, and 8 times a negative 4, that's a minus 32. The 8's cancel, that leaves you with a minus 3x. The 8's cancel, and that leaves you then with 15. We want it in standard form, so that means we move the 3x over, and we add the 32 over as well. Rewriting, we then have 3x plus 8y equals, and we've got 15 and 32, so that makes it a 47, it looks like. And is that in standard form? Yes, it is. How do we handle a line equation when we have a slope of 0? Let's try to write this one. This one we're going to, again, write in standard form. This one's going to have a slope of 0. How about minus 5, positive 9, and how about 4, positive 9. So I want you to, again, write this one in standard form. And this one's a little bit different because we don't have to do a lot of work here. Let's first find our slope. So that's the first thing we're going to do. Whenever you're given 2 points, is you're going to find the slope. And that's y1 minus y2 over x1 minus your x2, and x1, y1, x2, and y2. Now, what happens when I work with my slope here? Well, look at the numerator, the top half. 9 minus 9, that makes it 0. And minus 5 minus 4, that's a minus 9. 0 divided by any number is still what? 0. Now, what's special about our slopes? What's special about having a 0 slope? Does anyone remember what's a 0 slope? Is it a vertical line or is it a horizontal line? Which one? Okay, if we have a slope of 0, that means it's a constant function, so it's horizontal. Also look at your ordered pair. What is repeated here? If we notice here, the 9s are the what? Same. My slope is 0, so your equation in standard form would simply be y equals 9. That's it, because your slope was 0. Remember, y lines have a slope of 0. Now, what about an x line? Well, that's going to come from an undefined slope. So let's do one of those so you see the difference. Okay, so we're going to write this one again in standard form. And let's say you're given 2 points again. Let's say these points are 8, negative 12, and 8, positive 10. I want you to write it in standard form. Again, you're given 2 points, so the first thing that you always must do when you're given 2 points is you have to find the slope, and that is given by this formula. M equals y1 minus y2 over x1 minus your x2. And here's x1, y1, and x2, y2. Watch your signs as you fill it in. So you've got a minus 12 minus 10 over 8 minus 8. That makes it a minus 22 over 0. And that is not 0, that is undefined, right? So that is going to be undefined. Now, what do you notice about your ordered pairs? When you look at these ordered pairs, what do you notice about the x values? The x values are the same, right? And what do we know about an undefined slope? An undefined slope is a vertical line. So what are the same? The x parts. This is our undefined slope. So that means my answer would simply be now x equals what? X equals 8, because it's a vertical line now. Y lines are horizontal and have a slope of 0. X lines are vertical and have an undefined slope. We've got one more part to cover in this section, and we're going to talk about parallel and perpendicular lines and how they work when we want to find the line equation. So again, another flow chart, and we want to find the equation of a line given an equation and a point. So this is what we're going to be doing. So we're going to be trying to find the equation of a line, right, when you are given a line equation already and a point. So the first thing that we do, this is, I think, the most difficult one. The first thing that we do is we take the equation and we solve it for y. So solve the equation for y. And so that is y equals mx plus b, and you're going to have to find the slope. So find the m. So that's the first thing that you do, is you take the provided equation and you solve it for y, and that's going to give you the slope. Now from here, there are two different choices. It's either going to be parallel or it's going to be perpendicular. So let's talk about parallel lines and let's talk about perpendicular lines. Well, parallel lines, you're going to use the same slope. So parallel lines, you use the same slope. Perpendicular lines, you use the negative reciprocal. Or opposite reciprocal. Either way, it leads back to, either way you go, it leads back to this slope-intercept form, or sorry, a point-slope form. And that's y minus y1 equals m times x minus your x1. Either way, it leads back to it. So this is just basically like a little recipe that you follow. And then once you've got it in the point slope, then you either write your answer in standard form or you write your answer in slope-intercept. This is what we do. So we have to follow it down. So let's look at the whole flow chart here. And I'll leave the bottom half so you can get it copied, but let's go ahead and read it again. So this is for finding the equation. So we want to find the equation of a line given an equation and a point. We want to first take that equation and we solve it for y. That's going to give us our slope. And then the directions will either say parallel or perpendicular. If it's parallel, we use the exact same slope. We keep it the same. If it's perpendicular, we use the opposite or the negative reciprocal slope. Then we go back to the point slope formula. And then we either write our answer in standard or in slope-intercept form. So we'll have two examples of this, and then we'll look at an application, and then we'll see how much time we have left from there. So let's go ahead and look at another one now. On this one, I'm going to give you a line equation. I'm going to give you a point, and I'm going to have you write your answer in slope-intercept form. We haven't done many of those. So this one, we're going to write your answer in slope-intercept form. And let's say you're given a point. How about 5, -2? And I want this to be parallel to 3x plus y equals -9. So let's go through our steps. Make sure we know how to approach this one. If you follow the directions, it's not difficult. What do we have? We have a point and we have a slope. Or not slope, but we have a point and we have a line equation, right? We have a point, we have a line equation. So what do we need to do? Let's follow our flow chart. Point and line equation. We take our line equation and we do what? Solve it for y. So let's do that quickly. So 3x plus y equals a negative 9. We'll move that 3x over. So y equals now a minus 3x minus 9. My slope is the number in front of the x. So my slope here would be a what? Be a negative 3. That is your slope. Now make sure we follow the directions. This is parallel. So if it's parallel, we use the same slope. So we're going to use that same slope, which is a negative 3. So we're going to use that same slope. So now we proceed to what? Okay, now we proceed to point slope. Okay, so that's where we're going next. This is slope-intercept form eventually. So now we're going to use point slope. And that's y minus y1 equals m times x minus your x1. And we have our slope that we're going to be using, which is a negative 3. And we have the 0.5, negative 2. Fill it in. x1, y1. And that is y minus a minus 2 equals minus 3 times x minus 5. Now, when we work these out, we have to be very careful and watch for double negatives. So if we have a double negative, we make it then a positive. And we're going to distribute this negative 3 through. And that's going to give you now y plus 2 equals a minus 3x. Negative and negative makes it a positive 15. We want it in what? Make sure we know. We want it in slope-intercept here. So how would I get this in slope-intercept? There's only one small step. Move the 2 over, and we are now done. So what's my answer? Y equals a minus 3x plus 13. And that is your answer in slope-intercept form. Not difficult as long as you follow the directions. Let's do one more. We'll look at some special cases. And then if we have time, we'll look at the applications. If we don't, then I'll leave them for you to do. So let's do one more. And let's write this one in standard form. And let's say you're given an ordered pair. How about you're given the ordered pair 1, 2. And let's say you're given perpendicular to this line equation. X plus y, well, let's see. How about 4x plus y equals 9. So that'll be our line equation there. So making it pretty simple. Okay, so what's the first thing we do? We go back and we look. Okay, what do we have? We have a point, right, and a line equation. So we take that equation and we solve that equation for y. So let's do that. Move that 4x over. Easy enough. So y equals now a minus 4x plus 9. So my slope here is a negative 4. But we are not going to use the negative 4. We want the perpendicular. And what does it mean if we have a perpendicular line? That means we use the negative or the opposite reciprocal slope. So what is our slope right now? Our slope right now is a negative 4. So we take that negative 4 and we flip it over. So that makes it 1/4, and we change our sign. Right now it's negative, so that makes that positive, and we flip it over. So that becomes a positive 1/4. That is the slope that we're going to be using. So when we want perpendicular, we flip the fraction over, and we change our sign. Now, we can proceed to use point slope formula, and then write our answer in standard form. And your point slope formula is y minus y1 equals m times x minus your x1. And we're going to be using that point 1, 2. And we're going to be using that slope of 1/4. Let me write it so it doesn't look like a negative of 4 there. So we're going to be using m equals now a positive 1/4, right? So that's what we have. I'm in the middle of a lecture, but let's see. Okay, that one you're going to have to work out, right? Because you've got to set the denominator to 0 and cross multiply. Remember, you can't skip through them. So I go back and look at that one again. And I'll be able to help you in just a minute. Well, let me finish up the lecture here. Okay, so we have a point, and we have the slope that we're going to be using, which is a 4th. So our point is x1, y1, and we'll fill that in as y minus 2 equals our slope, which is 1/4, times x minus 1. We're going to distribute this through. And that leaves you then with 1/4 x minus 1/4 here. And the other side is a y minus 2. Now, can we have fractions in standard form? No. So we're going to go ahead and clear out our fractions. And how do we do that? Well, we're going to multiply everything by a 4. So let's rewrite it now. I'm multiplying everything by a 4. And that gives you 4y. 4 times a negative 2 is a negative 8. 4 is canceled. That leaves you with an x. 4 is canceled. That leaves you with a minus 1. I wanted this one in standard form. So to get it in standard form, I'm going to move the x over and the y. Sorry, not the y, but the 8 over. So move the x over and move the 8 over. And now we have a minus x plus 4y and minus 1 plus 8. That makes it a 7. Is this in standard form, though? Nope. Why not? Because the negative. So let's fix that. And what does that give you now? Negative and negative makes it a positive x. Negative and positive makes it a minus 4y, which is fine. And that equals a negative 7. I want to look at 2 more really quick questions. I'll go ahead and pass out the sign-in sheet, and we're almost done for the class. So just about 5 more minutes, and we'll be finished. Here's the sign-in sheet. Okay, now let's talk about what happens when you have an x line or a y line. So we'll do a couple of these. These do not take long at all, and these have to be written in standard form. So we're going to write these in standard form. Let's say you're given the point 8, negative 12 parallel to x equals 5. On this equation, or sorry, on this question here, there is absolutely nothing that we need to do. We need to remember about parallel and perpendicular lines. Now, what do we know about parallel lines? Parallel lines are going to have the same slope. So if this is parallel to x equals 5, we want the x component of our ordered pair. And what's the x component of our ordered pair? The x component of our ordered pair is 8. So the answer would simply be x equals 8. Nothing to really do. Right? You just want the x component of your ordered pair. Now, what about if it was a y line? Oh, yep, thank you very much. And you skipped 3 of them, right? Oh, yep. I'll get that graded for you. It shouldn't take long. I'll probably work on it this afternoon or tomorrow. You're welcome. So let's write in standard form again. And let's say you're given a point. How about, let's not use 8. How about 18, negative 2? And let's say it's parallel to y equals 10. Now, the key word here is parallel. Parallel lines have the same slope. This is a y equals 10 line. So what's the y component of this ordered pair? Negative 2. So what would your answer be? There's not much to these at all. Y equals what? Negative 2. One more, just so we know about parallel and perpendicular both, and then we'll talk about our homework. So one more quick question here. So again, we're going to write this in standard form, and let's say you're given the point 9, negative 3, and we want this to be perpendicular to x equals 10. Now, what do we know about perpendicular lines? Perpendicular lines are the opposite reciprocal. Okay, so they're opposite. Well, what's the opposite of a zero slope? An undefined slope. What's the opposite of a x line? That would be a y line. So perpendicular means the opposite. So what would the answer here be? Easy enough. Y equals a what? Negative 3. Now, what's going to be our homework for next class period? Which will be a while. But we finished up today 2.5. So your homework is 2.5, and you should be able to do them all. Now, also, just so everyone knows, there is no class on Thursday. March 9th. Okay, so don't show up to class on Thursday. We're not going to have class. That's math relays, and we always cancel all of our classes because we bring in a lot of high school students.